In a previous video, I'd shown just as a quickie off-the-cuff example for making a custom macro library, an improved version of the simple increment or decrement macro node. As pointed out by one of the commenters, in other programming languages and in C++ as well, outside of blueprints, they also have plus equals, minus equals, what are called compound operators. And basically, the purpose of that is, you can see here, you have a whole lot of nodes to do a very simple thing. So what I wanted to do was create a better version of my better version of the increment macro node. So what I came up with is the compound operator node, or the compound operator macro, which allows you to perform lots of different math calculations on a value within a clamped or wrapped range optionally, all within a single node, so that you don't have to have all this spaghetti every single time you want to do a simple operation like this. And the macro works great. There's no problems there. But I ran into something interesting that I wanted to share because it helped me understand better how the internal logic of blueprints works, and also to improve performance and streamline things, because you want this operation to be quick and simple. You want to be very efficient. And what I was finding is, we go in here into my macro, basically just takes the information, depending on a select on what type of operation you're doing, is what type of math input it takes, feeds it out to a wrap if wrap is selected, feeds it out to a clamp if a clamp is selected, and then it sets the value, and it also returns the value so that you can use that value in a check like this one here. But what I found is, after in my previous video where I was showing how exactly functions work, specifically pure functions, these are all pure functions, every single one of them. Right here, things break down a little bit, because what is happening right here is I'm setting the value, right, and then I'm returning the value. But as we previously covered in the last video, when you use a pure function, every single time you pull on this output pin, this gets rerun. And because every single one of these are also pure functions, they all get rerun. And so what ends up happening is, doing this doubles all of the work. It makes everything happen twice, which is very, very inefficient. And so the solution, you would think, would be, okay, well, we'll pull this only out once. We'll store it in a variable, and then we can use the variable here and here. Well, the problem is, I thought, you can't have local variables in macros. You can have local variables in functions. So one solution to this problem would, of course, be, I'll just take all this and I'll put it in a function, which I was about to do. And you can do. This particular thing that I'm doing would work perfectly well in a function. So you could use that as a solution. But I looked at, well, how do they do it with the increment function in the standard macros? So here is the increment function, which is a very simplified version of what I'm doing. Mine is bigger and more complicated, but it does basically the same thing. And it's not using what I'm using. If we go back to my macro library, I'm using set float by reference. When we go to the standard macro, it's not doing that. It's calling another macro. Well, why is it doing that? Well, let's take a look at that other macro. Now, that I added in as I was trying to figure things out. I wasn't sure, for the life of me, I could not figure out what is going on here. And I went into the Discords and I asked a few people, and several of the people that responded, they had no idea what was going on here either. It looked very confusing. And finally, after enough discussions, we figured out you can actually have local variables in macros. it's just done in a weird way. So rather than going over here and creating a variable and then pulling the getter or the setter out in here, like you would normally do, when you want to work with a local variable inside a macro, you use this weird little function. And it creates a temporary generic variable. And then what you do is you use a pair of set float or set int, set variable by reference nodes. The first one is setting the temporary variable you've created to the past value. The second one is setting the past reference to that same value, because the value is being assigned to the temporary variable. So remember, every time you pull from this pin, you get the current value, and the value is constantly changing. So the value gets changed here, the changed value gets passed in here, and then gets returned here. So this is doing what I wanted to do, which is, if we go back to my macro library, what I wanted to do here is put this value into a temporary local variable so that I didn't rerun all of this twice, which I thought couldn't be done in macros because I thought macros didn't have local variables. It turns out they do, they just do it in a really weird way. So that's why when you look in the standard library at their increment functions, where are we here, increment float, the reason why they use this weird manipulate float internal macro, it's just so that this weird convoluted way that you can use local variables in macros. So I just found this interesting. I thought maybe you guys would find it interesting. Hopefully you found it helpful. Have a good one.